So a common application of parametric equations is what we call projectile motion. We're interested in how far an object moves and how high it goes. So what we're looking at is we have an object and it goes like this, and we want to know this value and we want to know this value. So how high does it go, and how does it travel vertically, and how does it travel horizontally? So this is motion in the x direction and the y direction. So if we have a projectile, we also have, when it's fired, it has an initial angle that it's fired at. It might have an initial height that it's fired from, and it also will have some speed that it's fired. So because it has to go at a certain speed, think about like a vector. So it has initial speed magnitude of v naught. That's my initial speed. So now I can write some equations. So x, think about when I have this, right? I have my theta, right? X is going to be that v naught, because this is v naught here, v naught cosine theta times t in time. So how's it moving in time? And then y we have to think about gravity. So it's negative 1/2 g t squared plus, again, that the horizontal portion there, v naught sine of theta times t, and then I have to remember to add the height. And this looks very similar to what you may have done in previous classes when you talk about the path of something when you throw it. You just don't usually talk about the x part, you only talk about the y. So g is a gravitational constant, and actually it's acceleration. Right? As something falls, it keeps on going faster, and it's acceleration due to gravity. And it has two values. It's 32 feet per second, or it's 9.8 meters per second squared. So this, if you're working in meters or feet, you have to use different ones. So this negative 1/2 g becomes either a negative 16 or negative 4.9.